All right. Hello again, everybody. We're back for round 3. This time we're talking about angles. It's our topic. So let me give you some background information about that. First of all, let's see what an angle is. I'm going to draw an angle up here. Take a look at it while we talk about how to name an angle. This is going to be point R right here. We'll talk about that more. Point S. And point T on this side. Okay, so here's a definition of an angle. An angle is a figure formed by two rays. You can also call them sides of the angle. And they have a common vertex. The two rays have a common vertex, or a common endpoint called the vertex, I should say. Those two rays have a common endpoint called the vertex. And the vertex in this case is point R. So that's the vertex. All these points inside the angle are said to be in the interior of the angle. So that's the interior of the angle. And then all the points that are outside the angle are said to be in the exterior part of the angle. Okay, ways to name that angle. There's different ways. We could simply name it by its vertex and say that's angle R. You could use 3 letters as long as the vertex is the middle letter. So we could say this is angle SRT. Again, the vertex has to be the middle letter. And you could also say angle TRS. Notice I put that little angle symbol in front of the 3 letters, angle TRS there. Sometimes we'll see numbered angles. So let's say we got the number 1 inside there. We could also say that's angle 1. So those are different ways to name an angle. Okay. Okay, so now we talk about the measure of an angle. The measure of an angle is in degrees. So we say an angle is 35 degrees or whatever. 1 degree is 1/360th of a circle. Because you might know, we haven't talked about this year, but you might know from a previous class that circles have 360 degrees. So 1 degree is 1/360th of a circle. Okay. Next, we're going to give you some types of angles. First of all, we have this type. And that's called an acute angle. That's an acute angle. And that's an angle between 0 and 90 degrees. You see the degree symbol there. In case you've never seen that, I think you have, though. Another type of angle that we have in our collection is a right angle. So a right angle. And that's an angle exactly 90 degrees. And we usually will show that with a little square in the corner like that. That's a right angle, exactly 90 degrees. We also could have an angle that looks like this. Which opens a bit wider. That's called an obtuse angle. Obtuse angle is between 90 and 180. So between 90 degrees and 180 degrees. And then finally, we have a straight angle. It looks like a line, but it's actually could be thought of as an angle. It's a straight angle. And a straight angle, you can think of it as formed by two opposite rays. You can see the opposite rays there. Opposite rays have a common endpoint and they make a straight line. But that's a straight angle is exactly 180 degrees. Okay, so that's what an angle is. That's how you name it. That's the types of angles that we have. And now let's talk about congruent angles. We had already had congruent segments. Now we're going to talk about congruent angles. So congruent angles are simply angles which have the same measure. Just like congruent segments have the same length, congruent angles have the same measure. So I'm going to draw a couple angles up here. We'll talk about how to say they're congruent. So my first angle is going to look like this. It's going to be angle ABC. And then I'll draw another angle right next to it. And I'll call that angle DEF. Okay, so these angles are congruent. Let's just say they both have a measure of 30 degrees, whatever. They're both, let's just say they're congruent. So the way we would write that is angle ABC is congruent to, you all remember that symbol, angle ABC is congruent to angle DEF. Because they have the same measure, they're the same number of degrees. So remember when we talked about being fussy? Well, here's more of that. So the angles are congruent, but their measures are equal. So we would say that the measure of angle ABC, so that little M you see there in front of the angle symbol stands for measure. So the measure of angle ABC is equal to, no, it's not congruent here because we're talking about numbers. So the measure of angle ABC is equal to the measure of angle DEF. So if you look at those two statements, it's the same thing as we did for segments. Segments are congruent and their lengths are equal. Same thing for angles. Angles are congruent, but their measures are equal. It's a slight fussy difference that we always make in mathematics. Okay, and we can also, just like we put little tick marks on line segments, we can also put little arcs, these little curvy lines here inside angles to show that they are the same. They have the same measure. They're congruent angles. Okay, just like we had the segment addition postulate, we also have the angle addition postulate. The angle addition postulate. And here's how that works. Let's say I've got an angle right here. It's kind of wide. Angle RQP. And then I got another ray inside that angle, like that. And a point on that ray would be point S. Okay, so you see these two angles here. Actually, there's three, but let's say the two smaller ones inside the larger one. So I'm talking about angle RQS now. So we would say by the angle addition postulate, the measure of angle RQS, let me highlight that in yellow. So the measure of this angle plus the measure of angle SQP, that's going to be the green one right here. Those two measures, whatever they are, whatever numbers they are going to add up to the measure of the bigger angle. So the measure of angle RQP. So just like two smaller segments might add up to a longer line segment, two angles, the measures of two angles that are inside a bigger angle, the angles, the measures of the two smaller angles would add up to the measure of the larger angle. So that's the angle addition postulate. So I get an example for that one. Example. Okay, so this time I have an angle ABC. And I have a ray inside there, ray BD. Let's say I'm given the measure of angle ABD equals 37 degrees. And let's say I'm given that the measure of angle ABC is 84 degrees. And let's say that we are supposed to find the measure of angle DBC. Okay, so ABD, and you can, when you do your homework, you can write on your paper and redraw this if you need to. The measure of angle ABD is 37 degrees, so I'm going to write that right in there. That's 37 degrees. ABC is 84, so that's this one in yellow. And we're trying to find the measure of angle DBC, so I'll put a question mark right there. That's what we're trying to find right there. So that was 84 degrees for the big yellow angle. So by the angle addition postulate, we know that the 37-degree angle plus the one we're looking for must add up to 84. And so it's a subtraction problem. So the measure of angle DBC must equal the 84 degrees for the big angle that holds the two smaller ones inside, minus 37 degrees. So it's like the angle addition postulate, except we're going to solve this by subtraction. Okay, so 84 then minus 37 is going to give us 47 degrees. So that'll give us this angle right here. That angle is 47 degrees because 84 minus 37 is 47. Okay. Okay, we had segment bisector. Now we have angle bisector. What's an angle bisector? Well, it's simply a ray which divides an angle into two congruent angles. So an angle bisector is a ray which divides an angle into two congruent angles. So if I have an angle, let's call this LJM, and then if I have a ray which divides this into two congruent angles, so my ray will be JK, if that's there so that these two angles right here, which were formed, are now congruent, then we say this ray, let me give it a name, ray JK, that's the angle bisector. It's the ray that divides the angle into two congruent smaller angles. Okay. So we would say in this situation the angle LJK, angle LJK is congruent to angle MJK because of the angle bisector. All right, I have one more example, and that's it for the notes. Here it is. Okay, so I'm going to draw a figure up here. And what you see here is angle ABC. And then we are told, and you do have to be told because you cannot go on the appearance of the drawing, you're told that ray BD bisects angle ABC. And let's say we're given that the measure of angle ABD equals 6x plus 3. That'll be in degrees because we're talking about angles. And we're also given that the measure of angle DBC equals 8x minus 7. Again, that's going to be in degrees. And we are asked to find the measure of angle ABD. So if it helps you to trace these, you can kind of look at it. So we know that this angle ABD is 6x plus 3. And likewise, we know DBC is 8x minus 7. So put that in green. But we know that the yellow angle and the green angle are congruent because we were told that ray BD is a bisector. And so we can take this expression for DBC and set it equal to this expression for angle ABD. So those two angles are congruent, so their measures are equal. So that'll give us an equation, right, which we could solve for x. And once we know x, we can plug it in and find angle ABD. So we'll set 6x plus 3 equal to 8x minus 7. I'll do one thing at a time, otherwise I might start making mistakes. So I'm going to subtract 6x from both sides. And we'll add 7 to both sides. Divide by 2. Now you're tempted to stop right there, but remember we got a question we have to answer, and the question is, what is find the measure of angle ABD? All right, so we know that the measure of angle ABD is 6x plus 3, so 6 times our x, which we just found, which we said is 5. So 6 times 5 plus 3, so that's going to give us 33. And don't forget we're talking degrees here. So it's going to give us 33 degrees for that angle that they requested. Okay, so that's it. Let me summarize a little bit. So we talked about an angle, talked about ways to name that angle by using just the vertex or maybe an inside number. We talked about using 3 letters as long as the middle letter is the vertex of the angle. We talked about the measure of an angle versus which is a number. And so measures of angles are equal, and then angles themselves are congruent. We talked about acute angles, which are less than 90, right angles equal 90, obtuse angles greater than 90, straight angles equal 180. And we talked about how angles can be congruent to each other and their measures are equal. I think I already mentioned that. And we can measure that with little arcs. And then finally, we talk about angle bisector. An angle bisector is a ray which divides the angle into 2 congruent angles. All right, there you go. So that's all you need to know about angles so far. So not a bad, not a difficult lesson today. So we'll talk to you later.